um, getting us to kind of behold our own condescension a little bit, meaning, I don't think I'm going to impress you, and I don't plan to impress you. So there's going to be clarity in this, I hope, because I want you to see this presentation in the way that a child would. And the reason I say that is because I sat there and thought, I mean, I have 3 older kids, I have 2 younger kids, and I'm like, man, they need to learn how to code. They just have to. And I remember when I was a kid, growing up, my dad was an electrical engineer, and we bought, my family, as a child, my parents bought, a Tandy Radio Shack Model 80. Some people know them as TRS 80s. Some people call them trash 80s. And we had one. And it was black and white in all its glory. And it's stored on an audio cassette. How many of you have ever seen in real life a TRS 80? Impressive. How many of you have seen the little laptop edition? The small one. That's Rick Stallings. All right. So we had a TRS 80, and I didn't use it that much. There was a booklet, and it went through basic code, and I remember just literally character by character and a little bit line by line putting in the code, and I wasn't doing any programming, and I am not a programmer. My training is in networking and some systems administration, and my discipline these days, and has been for the past several years, is a full-time security analyst. And so that's my background. And I want you to know that the things that we're going to talk about here, they are very basic. They're very basic, and they're basic by design. And you'll see that in a few minutes. But we're just talking about fundamentals. And so if you get up and leave, it is not going to hurt my feelings. In fact, I'm kind of warning you now. We're starting from the ground up. There's no research involved here. In fact, the research started decades ago. I'm just piggybacking here and borrowing some content, which again is going to be real obvious soon. And yeah, it's not designed to impress you. So our story starts with a gentleman by the name of Seymour Poprad, is how you pronounce his last name. He passed away a few months ago, but he specialized in, and you're welcome to look him up, I would recommend it, he specialized in applied math and artificial intelligence, learning and epistemology, how it is that people learn, and very specifically how it is that children learn. And he was known for many things, but one of the biggest things he was known for was this one laptop per child initiative. In 2006, he got in an accident, an auto pedestrian accident, and it took 3 years to rehabilitate him to the point where he could move and go about his day, and he had some complicated speech issues involved with the accident. The actual rehabilitation team that helped him used his own research, experiential-based research, to help him to speak again. One of the things that I think is interesting is, as I was looking about my own life, I have these kids, I've told you about it, and language gets to be a big part of this kind of thing, learning how to code or write scripts, which is what I can do. I can read some code as well and pick it apart and modify it. I'm probably like most of you in that way, borrowing from other people's work. But I've watched these 3.5-year-olds of mine grow up, and it's interesting the way they learned to speak. Now I'm going to go back, but how many of you have nieces, nephews, kids of your own, grandkids, whatnot, or have seen a child grow up over the course of a few years of time? So it's phenomenal. In fact, it's so mind-racking and frustrating that I don't necessarily think I've paid attention before like I have in the last few years. But when it comes to language and how it is that they learn how to speak a language of the type English, they are building from a cultural construct being instructed by you as a parent, and you don't even know that you're teaching them. because you didn't know when you learned in the first place that you were being taught. So what I wanted to say was, initially they start to cry, and you think they never stop crying. And then there's coos, and there's these babbles, or proto-babbles. They're just starting to fit things together and starting to speak. Then you get proto-words, monosyllabic words, just little tiny words, and you have to figure it out, and you and others around you that are watching these kids learn these things, you put together, oh no, I think he or she's saying this. And then you start to understand what they're speaking, and next thing you know, they're saying a word, and then they're saying two words. And it is an ongoing, iterative combination. Here's an example. One of my daughters, she says, instead of, excuse me, pardon me, she's right to this moment, she's saying, excuse me, part of me. And it cracks me up every time I hear it, because she knows what she's saying, and we know what she's saying, but she hasn't quite gotten the code right yet. And that's okay, but she has pieced together what it is that she's trying to say in an iterative fashion, and we're communicating. Now, here's something I wanted to say as well. There has never been one moment in my kids learning how to speak their language that they made a deliberate decision to do so. They don't even know what English really is, right? But they have an innate ability to learn. And for me, it has not just been steps, it has been an observation. I didn't teach them to speak. Well, I've just spoken and tried to help them out with it. But they have an innate ability to learn, and I think that's fascinating. So let's go back to Mr. Poprad and watch a short video clip of some of the foundations of his idea. Wes, am I going to be good for audio?
This is an attempt to make a sketch of what a school of the future might be
From
like.
1986.
Now, nobody really knows what the future will be like, but we know what it won't be like. We know it won't be lots of children sitting in desks with pencil and paper writing all the day. We know that these new technologies, these computers, will be an important part of it. If you go into any school or any home, you'll find many pencils, many crayons, many paintbrushes, because these are instruments that people have made part of their lives. They use the pencil whenever they have a need for it, to draw, to write a story, to calculate. And so with the computer. It's the natural instrument for doing mathematics, for music, for 100 other things. And our goal here is to make it sufficiently part of the culture of the place that everybody uses it when it's needed. There are many aspects to what goes on in the school. We see children here writing stories. In other parts of the school, we see music. We see very special projects like Lego Logo. This might sound like playing with toys, but that's just what's so clever about it. They are playing with toys in a very sophisticated way. The Lego Logo project is one in which children build with the construction set Lego and then interface their construction to computers so that they can control them. The children are learning to program. They're learning important ideas about motion, about feedback. They're learning principles of engineering design. Above all, they're learning that knowledge is a unified thing, and that the scientific and formal and mathematical knowledge is not something separate from their passion for toys, from the things they did since they were small children before they even came to school.
So it's interesting to watch that again and pick it apart. So that was Seymour Poprad. He's the gentleman that started the foundation of what's called Scratch, the programming language. How many of you have ever heard of Scratch or Scratch Junior? It's absolutely phenomenal. And honestly, this is what we're going to speak about. So it is a conceptual walk together right here at this presentation, what we're doing. I'm not a coder. I'm not a programmer or software developer. When I grow up, I'd like to be one. I think that'd be cool. But I do piece things together. And part of this is going to be a progression of ideas at a very low level that I would recommend you walk through on your own. Most of the resources that I'm sharing with you are freely available. There is one thing that I would recommend that's at cost, and it has nothing to do with personal gain for me, but it just depends on how much it is that you want to look into these things to learn for yourself or to learn as a child or help a child learn. And it involves Scratch Junior, which at a foundational level is designed for 5 to 7-year-olds. So I have a book that is specific to learning Scratch Junior. I've read through it, I've marked it, and got done with that about 2 months ago. And my youngest, my daughters, my 2 identical twins, they're 3.5. Well, guess what? They're not going to learn that. They're not going to learn that. But we flip through the book, and we look at the Scratch cat, and we look at the pictures and things like that, and they're gaining familiarity for something that they'll hopefully latch onto in a couple years. We'll see. But the funny thing is I don't necessarily intend for them to be programmers. That's, in my mind, a big part of their own decision. But I do think that everybody going forward should know how to do some code, starting from there. So there's Scratch Junior, which you can get started with at scratchjunior.org. I have it installed on a tablet at home. It's pretty dang cool. I haven't let my daughters mess with it yet because I'm still trying to figure out how some of the interface works a little better, and then go through building the dialogue in my mind that's going to be helpful to them to actually play with it and enjoy it, not have it be an exercise in frustration. And then scratch.mit.edu is where you get started looking at Scratch, and that's where we pick up for the programming element that's been developed for children that are aged 8 to 16. But it's really cool. I didn't bring my backpack to the podium, but I'm working through that book now. And that's, again, for my hopeful intentions, that's a few years away from when my daughters will even be ready to dig into it, or put myself in a place where I can understand how it could be helpful to them. So at the end of Seymour's clip from 1986 a few minutes ago, he said something really interesting, and you're welcome to go find that video on YouTube and rewatch it or look into some of his life and his research. But he mentions play, and he talks about how kids learn things based on how it is that they learned how to play before they went to school. And a big part of Scratch and what it's about, as I understand it, is not just to have computers and technology entertain us. It's not just about that. It seems like it's just about that. For most of the folks that engage with technology, it is very entertaining. Our movies, our devices, games, all those kinds of things, and it's fun. But what Seymour and others wanted to do was to develop an intuitive, innate ability to learn and use technology as a tool, and specifically software, learning the fundamentals of programming and how math, logic, rationality works. And so the point was, is it entertainment or utility? No, it's not a black or white thing. It's not like that. It's both. And so we have another video that we'll watch in a few minutes, and hopefully you can see how kids could latch onto this, or adults that are wanting to work through it and understand some fundamentals could latch onto it as well. The neat thing about Scratch Junior, starting right from Scratch Junior on your tablet, is you can build very basic animations that involve multiple characters, or as they call them, sprites in Scratch, that you can have games and competitions, and that they can become interactive, not just for what's happening on the stage, what they call the stage, but for the person that's interacting with it as well. So it does gamify it. It does allow them to build something that's gamified, but they also know what's happening behind the scenes. It's not a CLI. It's not command line. It's a GUI, and you'll see it. But it builds on constructs, and it has for me, built on constructs of understanding that I have already learned and used doing just basic shell scripts and working through basic programs and borrowing other people's code, for work or personal reasons, that I already knew, that I looked and thought, this is genius. This is actually really cool because now I can see it and understand it. And I feel like, just telling you, I feel like I understand things better as a non-coder, but somebody who uses code, now that I have learned and I'm continuing to learn Scratch. There are corollaries, meaning I'm not going to provide you with a mapping. But you could, if you speak or understand code, whether it's Perl or Ruby or Bash or batch scripting, or whatever, you could look and see that there are corollaries to what Scratch is doing to try and develop these basic elements of understanding with what kids could, or adults aspiring to understand code, could go on to apply to real-world exercises. And I have a challenge for you at the end that you're welcome to get in on if you want, that will help you apply some of those skills if you'd like. So this is a basic picture of the interface for Scratch Junior. I'm not going to go through all the pieces because I would recommend, if you're interested, that you go through them yourself. www.scratchjr.org/learn.html. And as you hover over each one of the numbers, it's going to pop up with a brief explanation on the right side, like there, where it says this is what you click on to save the current page and exit to the home page. And I'd recommend, if you're interested, that you just bump through it and familiarize yourself with it. That's Scratch Junior. This is what Scratch looks like. So Scratch Junior, that's 5 to 7 is the target age group. Scratch, just Scratch, that's 8 to 16 is the target age group. And so the interface gets a bit more complex, but what is absolutely incredible, I think it's really cool, is you start getting into deeper iterations and the ability to tie other scripts together. And then you start to see how hooking can work and how modules function, depending on the language that you're familiar with. Looping, all kinds of constructs exist. How to slow things down, how to speed things up, how to only do things a certain number of times or do them until you hit, a certain number. And all the fundamentals are there. In fact, it's really funny. Some of the computer science things that I have studied and that I do know, I look and I can see how they are so perfectly made to fit underneath Scratch and Scratch Junior. So let's watch another video. I think this one's 4 minutes or so. And I picked this video specifically because there's not a lot of talking. It's just like you're driving it, and it's just an exercise in the iteration of using it to learn some basics of programming.
Glub, glub, glub.
All right. Funny.
Glub, glub, glub. Glub, glub, glub.
So, apologize for the cheesiness, but how many of you got the point? Saw what it was doing. How many of you want, you don't have to raise your hands on this one. How many of you would like to download this and spend 15, 20 minutes just to see how it's working? Yeah, I'm going to tell you right now, it's pretty dang cool. And it's the kind of things that I think kids should have in front of them on a piece of glass when they're 4, 5, 6, 7 years old. Not to say they can't just have fun and play either, but I also think this needs to be a part of it. And I think it's the kind of thing that would hook them. And the next thing you know, their play would become utility, and their utility would become great for them to enrich their lives and to give them a path for other options that would come before them in the future as they were students and moved on into a career. So I have a challenge for you, and you're welcome to try it for yourself, or just DM me. I'm going to give you a slide at the very end that's got a link for my Twitter account, and you're welcome to follow, DM, and unfollow. I'm not trying to get that kind of thing. But, or if you want to hit me up, jt@uen.org. jt@uen.org is my email address directly. You're welcome to send me a message that way too. But this is my challenge for you, and this is not to be done in Scratch, although I'll buy you lunch if you did. That would be freaking amazing. And you know what? I've wondered. I think there's ways you could do it. It might be a little funny, but so my challenge for you is to get Linux in front of you, and I know a lot of us have done that. It doesn't bother me if you run Linux or not, or if you can get, just whatever one of the distros is, the live distros that'll help you do that. And then I would say try to do this with Bash, the born-again shell, and you're going to be in a non-graphical interface in a CLI. And then I want you to go out and find a malicious IP list. What I mean by that is there are places where you can find, free of charge, okay, a basic threat intelligence type of malicious IP list. Don't grab the whole dang thing, but look to see if you can identify or find a way to see if there are malicious IPs within your organization for the space that you route from a network and internet protocol standpoint. And then take that list and build, if you'd like, a network-based access control list to be used either on a Linux box or a router, a network-based device, and then have that list be emailed to you. Now, this challenge, you don't need to do it. But this is something that I've been working through on my own, because I've done bits and pieces of this, and I've done bits and pieces of this years ago, but there are certain parts that I'm still trying to bolt together, and my own personal desire is because there's a lot of threat intelligence out there that you can have for a price. But when you start talking about meat and potatoes of security, I want to do something, one, for the challenge, but also I'd like to start putting together my own understanding in a better way. And so this is something that I'm working through as well. I've got most of it done. And if you'd like to see the code that I finish, then just email me or direct message me. Now, I told you I had a mission, right? So this is the reason I think it's important, like really important. Science, technology, engineering, and math You've probably all heard about it. And how many of you know who Michio Kaku is? Probably most, if not all of you. Really? Not that many of you know who Michio Kaku is? So he gave a pretty energetic answer to a talk show host. And he was talking about the use of an H-1B visa. And I don't think there's necessarily an issue with the H-1B visa. But we have critical infrastructures and innovation pipelines, meaning companies that build innovative technologies that can be taken to market for profit, that rely heavily on the H-1B visa program to bring in talent from outside of the United States, because there is a shortage of students and professionals with science, technology, engineering, and math skills to foot the bill so that those things can be developed from the population in the United States. So I want to share something else with you, why I think it's important that we try to catch up, in my opinion, and not rely so heavily on the H-1B visa. And it has nothing to do with political motivation. In fact, to be honest with you, I don't think it has anything to do with patriotism. I think there's a lot to be said about freedom and independence, about your ability to sustain your own economy or to build your own company, and source those skilled professionals from within your local region or area. How many of you know who Peter Thiel is? Okay, so Peter Thiel, I would look him up as well if you're interested in following up. His last name is spelled T-H-I-E-L. T-H-I-E-L, Peter Thiel. So Peter Thiel is an entrepreneur. And I would recommend, as you look into Peter Thiel, that you go get the notes from the class that are available online for his Stanford course that is numbered CS183. So Peter Thiel's Stanford class notes for CS183. And what he goes into there is, it's not just the basics of entrepreneurial stuff. It's like blood and guts and trying to figure something very critical out in my mind. And that critical thing is what I've got listed here on your right as N+1 versus 0 to 1. So how many of you know what globalization is? So somebody, if it's okay, somebody give me what's a definition of what globalization is? Non-political, just globalization. Anybody? It's distributed worldwide. So globalization is taking something like clean, potable drinking water and making sure everybody has it. There's nothing political about that. People need to drink water. So clean water sources being globalized is legit. Here's another thing that's globalization. Internet bandwidth to all corners of the globe. Now, I'm not saying like our wildlife spaces or heritage sites or anything like that, but we should be able to provide bandwidth to just about everywhere in the world because it enables business, education, civilization, health, food, water. It's a good thing, and I think that we could argue that safely without appealing to any political left or right or whatever ideology a person might hold on to. So globalization is N+1. It is nothing but making copies. Globalization is N+1. Well, we don't necessarily want to be in the business, like speaking about the United States economy, in my opinion, or any company or any endeavor where all we're doing is just making copies. It needs to be done, granted, but I think if we could strive to understand the language of technology, including coding better, then we can move into a space where we're starting to talk about 0 to 1. And Peter Thiel says, where N+1 is duplication or globalization, 0 to 1 is innovation. It is where you actually make something new. It is how businesses are built. It's how technologies are discovered and implemented, which then go on to be globalized, right? But I think it's really important that from a STEM standpoint, and in my opinion, an H-1B standpoint, we get more into the business of 0 to 1 and building, developing, hardening our innovation pipelines as an economy or a business or whatever it is that we do that's important, to include, in my profession, in my line of work, nonprofit, public education, and the technological support of that resource. So I think it applies to everybody. So where do you go from here? I mentioned to you the only thing that I was going to recommend for price would come near the end, and this is now. The first thing that I would do is I would go to scratch.mit.edu, if you'd like, and I would take a look at it and just see what's going on. It's pretty dang cool. If you share it with kids, nephews, nieces, or learn it for yourself like I'm working through it, then yeah, it's actually pretty dang cool. There is a wealth of information, like y'all know, on YouTube, and it is free for the most part, right? Who knows what they're selling? Just kidding. But then the one that's for price is, I would say, go check out No Starch Press. There are a couple really good books. I've got some of them myself, specifically for Scratch Junior and Scratch. And so that's a good place to start. Honestly, think that's all it is that I have to speak with you about. I hope this was a little different than what you thought, but I hope it's also like, oh yeah, I can go help myself now. And so when I said, behold your own condescension, it's funny when you're trying to learn how to code and you're not a coder. There's a lot of information out there, if you don't mind, being a little bit like a child about it, that you can use to learn for yourself. And it helps, because sometimes, this is my opinion, this is my personal experience, I consider myself a pretty technical person, and I think the people that work around me think I'm pretty technical as well. But I'm not technical enough for myself. There are things that I want to learn. And I've also tied in the fact that I've got some kids that I want to learn, and I think that it would be helpful to the economy and things like that too. I think it's something we should do that's got a future, and there's a mission related to it. So that's the gist of what it is that I came here to tell you. You can find me on Twitter. It's MYW3H. It's my way. And I'm pretty active on it. In fact, I check it almost every single day. And I'd really love to open up a channel with you. If you want my code for the challenge, just hit me up via email or a DM on Twitter. Does anybody have anything that they want to share, or any ideas or experiences with Scratch or learning coding themselves that they want to share with the group? I've heard about it. I haven't looked at it, Bert, but I want to look into that one further. One that I'm looking into now is from Kinder Lab Robotics, and it's kind of similar in that they're trying to bring it out into a physical kind of space, but I'll check it out. In fact, will you send me a note on that? Thanks, man. Right here. I haven't heard of that one. Really? What? So OSMO? Because that's the place where I'm at. So I've got my 3.5-year-olds, and I'm like, I'm not going to bridge a 2-year gap. Yeah. That's cool. Cool. Hey. So to repeat the point that Bert was making is, you don't need to have it on a tablet. It can run on a Pi, a Raspberry Pi, or a device like that. So it's not necessarily, or any browser, it's not necessarily a cost-prohibitive thing. In fact, that's not the point. The point is not for cost on any of this. In fact, that would tell you something, right? As to how important it is, and that this research has been ongoing for decades, plural, to try and get STEM skills injected into our educational process. Anyways, oh, Bert, tell me the one of it. It's something turtles, you said? Robot. Oh, you did too? Okay, robot turtles. Hey, so I don't have anything else for you, but I'm happy to speak with anybody. It's JT. Yeah, this gentleman back here in the orange shirt with the Saintcon on it. I've heard speak of them. Yeah. Awesome. So hold on. Troy's going to bring out some crypto coins. Hey, thank you all for coming out. Thanks for attending Saintcon. Hopefully this was helpful for you. Stay put so that these crypto coins can get out here. I'm going to drop this mic and call it good. But thanks so much for your support. Come back next year. We're hoping to make it bigger and better next year once again. So thank you all.